lesson is from Mrs. Cucci's College Now College Prep class. We are on lesson 4.4, linear inequalities in two variables, and we are going to be finishing up this unit with this lesson. All right, so what we're going to be talking about today is graphing linear inequalities in two variables. So we're going to replace the inequality sign or inequality symbol with an equal sign, and we're going to graph the corresponding linear equation. We're going to draw a solid line if the original inequality contains a less than or equal to or greater than or equal to. We're going to draw a dotted line if the original inequality contains a less than or a greater than. Second step is we're going to choose a test point from one of the two half planes. We're going to substitute the coordinates of the test point into the inequality, and if the statement is true, we're going to shade on that half where the test point is. If it's false, we're going to shade on the other half. Okay, so let's give one a shot. I've got 3x minus 5y is greater than or equal to 15. So first step, we're going to change that inequality sign to an equal sign. And we're either going to graph it by solving so it's y equals mx plus b, or we can use the x and y intercepts. X and y intercepts would be pretty simple for this one. So let's go ahead and do that. Find the x-intercept, you're going to plug in 0 for y. And we get x equals 5. Find the y-intercept, you plug in 0 for x. And you get -3. So let's plot those. Since it's this symbol here, right? This or this, it's a solid line. So x is 5, and y is -3. And this is going to be a solid line. So now, we need to decide which side to shade on, above or below. Okay? So this is where that test point comes into play. The easiest test point to use is 0, 0. Okay? It's the easiest test point we could possibly pick. So all we have to do is plug that in. We're going to use our original equation with the greater than or equal to. Okay? So we wind up with 0 is greater than or equal to 15. Is that true or false? Is this point here, is that greater than or equal to 15? I would say that's false. So that means wherever this point is, the point we just tested, if it's false, I'm not going to shade where it is. So that means I have to shade on the other side. So that's how you decide where you're going to shade. Okay? All right, let's try another one. So we've got y is greater than -2/3 x. So this is in that y equals mx plus b form. If there's no b, again, remember, if there's no b, the y-intercept is 0. The slope is -2/3. So I'm going to go down 2 and over to the right 3. Down 2, over to the right 3. Down 2, over to the right 3. Or I can go up 2 and back to the left 3. Okay? Because it's this symbol, it's going to be a dotted line. All right, now, next thing we need to talk about is a test point. Now, here's the problem. I'd like to use 0, 0, but because 0, 0 is already a point on that line, I can't use it. So let's use something else. How about we test 1, 1? That'd be an easy one to do as well. Okay. So again, you use the inequality they give you. Is 1 greater than -2/3? Well, yeah, positive number is always greater than a negative, right? So we're going to shade on the side where that test point is, because that was true. Okay. Graphing linear inequalities without using test points. So if it's in slope-intercept form, y equals mx plus b, if y is greater than mx plus b, we're going to shade above or to the right. If it's less than, we're going to shade below and to the left. But it has to be in this form, okay? If it's a vertical line, it looks a little bit different. So let's say x is less than 2. X is greater than 2. So let's say here's 2. Less than or equal to. If it's less than, it's to the left. If it's greater than, it's to the right. Okay? So left, right, up, down. So let's y. If it's greater than 2. If it's greater than, it's above. If it's less than, it's going to be below. All right, so this says above or right, below or left. Okay. So let's try these ones without test points. Y is less than or equal to -3. So again, that's a horizontal line at -3. And because it's less than or equal to, it's a solid line. Since it's less than, it's going to be below. X is greater than 2, vertical line, dotted. Because it's greater than, it's to the right. Okay, so how about we get into systems of linear inequalities? So having more than one linear inequality on a graph. Application. Does your weight fit you? The latest guidelines, which apply to both men and women, give healthy weight ranges rather than specific weight for your height. Figure below shows the healthy weight region for various heights of people between the ages of 19 and 34 inclusive. Inclusive means including 19 and 34. If x represents height in inches and y represents weight in pounds, so x is height, y is weight, the healthy weight region can be modeled by the system of linear inequalities. Okay, so that's your linear inequalities. So we're going to answer some questions that go along with that. So I want to show that point A, right here, that point A is a solution of the system of inequalities that describes healthy weight. So point A is the point 70, 170. Okay? I want to show that that is within the healthy range. So what I need to do is I need to test it to make sure that it's within the solution range, so this shaded region that seems to be falling in the middle here. Okay, so I need to test it in both equations. So again, my point is 70, 170, and I have to test it into both of those inequalities. 4.9, but instead of x, it's 70, minus y. So that's the first one I'm testing into. The second one, so I want to make sure that both of these are true statements. Okay, 4.9 times 70 is 343, minus 170. 343 minus 170 is 173, is greater than or equal to 165. That's true. 173 is greater than. Okay. Other side here, 259 minus 170 is less than or equal to 125. 89 is less than or equal to 125, and that's also a true statement. Okay. So the coordinates 70, 170 make the inequality true. Therefore, 70, 170 satisfies the system for healthy weight region and is a solution to the system. Okay, so that was basically like our test point, right? We tested it to make sure it was in the right spot to shade. All right, guys. Last piece here, almost. Graph the solution set of the systems. So we're going to go ahead and graph these out. Now, we can either graph using y-intercept or we can graph using x-intercepts and y-intercepts. So why don't we go ahead for this one and graph using the intercept. So we'll start with equation 1, and we'll find the x-intercept. So we know we have to plug in 0 for y. So x equals 1. Y-intercept. Y equals -1. So 1 and -1. X is 1. Y is -1. And it's going to be dotted. And we need to do a test point to decide where to shade. Okay, test point. 0, 0 we're going to use this time because it's not on that line, right? So we're going to plug it in. Is 0 less than 1? Yes. So we have to shade in the region where that test point lies. Here's the test point, right? So we have to shade in that region. Okay? Equation 2, x-intercept. 2x plus 3 times 0, and we can make this an equal sign right away. 2x equals 12, x equals 6. 2 times 0 plus 3y. 3y equals 12, y equals 4. There's your y-intercept. You should be quick at these by now. Okay, so x equals 6, and y equals 4. Now this was greater than or equal to, so it is going to be a solid line. And we need to determine the test point. So again, let's use 0, 0. Okay. 2 times 0 plus 3 times 0 is greater than or equal to 12. Is 0 greater than or equal to 12? No. Which means I need to shade in the opposite direction. It can't include 0, 0. Okay. So for solutions with systems, it's where it's double shaded. So this region here is where you're going to find your solutions, where it's double shaded. Okay. All right, one more. Graph the solution. All right, x is less than or equal to 4. So I know x equals 4 is a vertical line at 4. And since it's less than or equal to, it's solid. And less than is going to be left. Right? Y is greater than -2. So dotted line, horizontal. Greater than is going to mean above it. Your solutions are right here, where it's double shaded. They're also going to be included on this part of the line here, right on it, because it's solid, but it will not be included on the dashed. No solutions on the dashed, only on the solid. Okay, make sure you do the practice document, and next we start studying for the final exam. Thanks, guys.